Welcome to Wireless Applications and our dirt simple telecom tools. In this how-to video we are going to show you a case study using our tool we call Path eFinder. This is used for designing the straightest microwave routes using two distance endpoints. Among our greatest feature in SiteSync Pro is this tool that we call Path eFinder or eFinder for short. It is used for connecting two remote endpoints together and finding their lowest latency. The feature is available throughout the mapping area of SiteSync and triggered off of having many dots on the screen and then selecting two endpoints, and that gets it started. In this session we are going to show you an example of the uses as a part 1 video and then follow up with a part 2 series. This first section will be finding the shortest routes around a large mountainous radius. And then part 2 session will be directly related to the high-frequency traders and finding the most efficient route using eFinder's math modeling for the straightest lowest latency and the using the best towers. We will first start out by searching our target area for existing structures. So let's go ahead and click on Structures. We open that up. This zooms out to the whole United States by default. We are going to focus on the Yellowstone National Park, then up to Billings, Montana. An easy way to map zoom into areas is by having a mouse with a wheel. If we middle-click our mouse, hold down and then drag downward, we will zoom to that area. We are also looking for parts of Montana. Let's go ahead and go to the Google Map tab for a little more detail. And there we see Billings, Montana up there. And we are going to be looking at generating a microwave path network between West Yellowstone all the way up into Billings for our backhaul project. Our task for this is to look for a microwave system that we can build using eFinder. So once zoomed, let's go ahead and select the Automatic Zoom Area tool. In that navigation bar up at the top, if you just click on that little icon, it zooms to the US. But because we're going to be designing in this area in Montana a lot, let's go ahead and set as this preset too, then rename it to Yellowstone. Then hit enter. Now if we hit the United States icon, it will zoom to the whole United States, but because we're going to be working in this Yellowstone area we can just click it and it will automatically zoom to our spot. The next thing we need to do is get into the advanced options. For searching of existing towers, we are going to look at only two different databases. First the FCC database, and then the microwave database. We want the microwave database because it is unique for this type of areas, being that it is a mountainous area. Not all structures need to be registered with FCC or FAA, but with microwave, even if it's a 40-foot or 20-footer, those locations still need to be filed. For this search we're going to do something a little bit different than a normal drop ring search because it's a unique area. We're going to use the WAC tool. For this we click it once. This has 3 different options for various commands that are very useful. In this case we are going to hold down the Control key, because we want to make a polygon search area. Hold down the Control key, then we go down to the West Yellowstone area and left click once, then we drag our mouse upward. Every time we do a left click, it creates a data point for the polygon. We will go up to Billings. You can let go of the control button at this point. As we get closer to the endpoint, we can double left click the mouse and that will close your polygon up. Because we already have the database selected here, all we need to do is hit search. And this will pull up all the sites that we have available in the tool for those two databases. That's probably a couple million records nationwide that it's pulling from for these results. Although we could just run eReach between any 2 points at this time, we are going to go ahead and filter out many of the duplicates. Due to the microwave database, although you get a point where microwave shoots to, you also will get every license that's also at that location. When using the microwave database, there might be a location showing up with 20 records, but there's only really one site there, just a whole bunch of dishes or channels on that single mountaintop. To do this, we are going to send it to a portfolio to clean it up. Down below is all your data of all the site records that were found. We are going to go ahead and select all of them, then push these locations into the More Actions and then add sites to a portfolio. What we want to do here is push to a new portfolio and name as Yellowstone to Billings. Then very importantly, we want to make sure that we click Consolidate Sites. This takes every record, and if it's within 50 feet of other records, SiteSync will condense that into the tallest, best record. Let's go ahead and click this. After the process, how many sites will we get from this one? We have 1181 sites, and we can go ahead and open the new portfolio and see what we came up with. After the consolidate analysis, we're down to 440. It took and thinned out a lot of the duplicates. Next, we want to identify the two endpoints. The first one's going to be in West Yellowstone, so let's go ahead and rubber band zoom down to here. It's right downtown in the main area, and we're going to go to the main little data center that we have there. It's on this little tower, it's right in the middle here. What we want to do for the endpoints is identify them in a different way to make it easier for us find it in eFinder. We are first going to jump into more info, which opens up our pause and fix window. We zoom into that area, and all we really want to do is just relabel it for finding it quicker by adding the text 001_ then start, and then put that in both the site ID and the site name box. We will save and close. All we are doing is just making this list easier to sort. Let's now go into the Billings area. An easy way to get to a location resume to is this jump to location box up at the top right. Click that and you just start typing in the name of the city or a place you are looking for, even a zip code. You can also put in lat and longs by copy-pasting them. We want Billings, Montana, so typing and hitting enter zooms to it. We are going to go right down into the main part of the city, and there is a building right at the data center we are going to use. And we're going to do the same name change here. With this location we are going to use pause and fix again. And going to label this as 002 with the word stop in front of it. Now save and close. Then we can do the filter zoom icon here, and that zooms us back out to our data. What we've done here, after we resort, is we can easily find our two endpoints at the top of list. This is what we were after, was to identify those. We check box those two and we know we got the right locations quickly, and then go into more actions, then Path eFinder will show up as a potential action. Because only 2 points checked, only options that you can use show. We choose Path eFinder. Now the whole pop-up starts calculating averages of the heights and other analysis as it computes the data. What we need to do first is enhance the buffer range, because the default of 5 miles on the straight line will not collect enough sites for this test. Since there are very little sites in the mountains, let's push out to 55 miles. This encompasses all sites in our portfolio. Our default in here for path length is 3 to 60 miles. Let's lower that down to, let's say, 40 miles max. Maybe we don't want that long as we don't know the area. As it recalculates, if it can't find a way through with just the dots themselves, no terrain, it will give some warnings. Not seeing any issues, so let's go ahead and run. Other settings that are in here, such as terrain data, allow options for SRTM and others. You can select frequency bands, but it really does not matter at this point. We want a solution, if possible, through this route to see if there is anything. Assigning bands are easily done later in this video. There are settings for Fresnel for clearances, height selection from the data records such as best, or just tip height. You should leave it on best until you clean up your data with pause and fix. If there are sites with no data on heights, then 97 feet will default, so at least the site is used. The cost factor slider is based off of latency versus structure type. We physically look at each structure type, if it's identified, and convert that into a WAC rating on how easy it is to put microwave dishes on that type. If it's just a small pole or flag pole, it gets a rating around a 0. so that the tool doesn't use it due to if it's a 6-foot dish, it is unlikely to get mounted. We have results. There are 7 hops for our first trail, and 10 total trail when found on routes through. The very first thing we see is that it was not a straight line. Although it would have been nice to get over this mountain range, the reality is it's all national park land. Getting new sites is pretty slim. However, eFinder did find a way out by going north and then following I-90 right into Billings. eFinder finds up to 10 trails. In this first area here we have our first trail, which is all the orange paths. If we click the plus icon, it'll show you all those 10 paths, the heights of each structure, and the path lengths. If we mouse over the total length, we'll see that it's 34 miles out of being straight, with an efficiency of only 80%, because it did not get to go straight through the mountain range. If we want to clean up the map a little, because there's too many sites getting cluttered in the view, you can pull down Display Sites, and click Selected. This will leave on just the orange route and sites. If you have multiple trails that you want to see, you can hit Trails, and it will show the other sites that are part of those solutions. If we close this one, and were to click on one of these other trails, we would see that one of those sites were used. To see any of the individual paths, we can click on the orange path link in the map and it will show that path profile down here. You can also click that image if you want to see details. We will turn all sites back on. Statistics-wise, what did this tool do in this particular analysis? eFinder found 32,000 potential paths that it had to evaluate for clearance. They match our distance range. It had to check a total of 33 million ground elevation points to calculate all the clearances. What we want to do next is check out what all that looks like. Go over to the Possible and Failed Paths tab. This has multiple filters, but the easiest is just turning on the All Paths. eFinder saw 14,000 of the 33,000 RAN that made clearance. We can see from this layer, clearly, where the choke points are. There is a choke point in this area where everything looks like it all goes to this one location. As we go out further, we see additional choke points all throughout the West Yellowstone location. As we get up and over the I-90 range, then all of a sudden everything is available to get back into Billings. You can use these sliders to trim up the buffer ranges and the path links. To visualize how hard the tool worked, we hit the Failed Paths, and there's another 18,000 that it tried for getting straight through the range. We mentioned in the beginning with the settings section that the frequency range and a little bit of the min-max distance for paths doesn't really matter yet. Keep that in mind as we will get to that shortly. But what we can look at is this tab we call Analyze Bands. When we run this, it queries all the FCC licenses that show were built in this entire area, then looks per band. The 6 gig, the 11 gig, the 18 gig, 23 gig. Although it goes into the 80 gig, it's not pulled into the calculations as those distances can be basically a few hundred feet. What this is calculating though is all distance distributions of every single path that it finds. It found 1100 records here and then weights them with a relaxed range calculation. Then pulls all of those together. Then we do a overall calculated average for finding the minimum and maximum ranges. This means you don't have to be a super engineer, you just click for the answer. This particular area, with the terrain, trees, rain, etc., you can quickly see that the average distances are 4 to 59 miles. Now what we can do is just click this range and it will auto-load that back into the settings for our new 4 to 59 range. We can now run this again. As we see it processing, this time, 44,000 paths are being ran to look for the next best route through from A to B. As this goes through the calculations, it will also be analyzing all paths to try and get the straight route from ones that are clear, trying to bring down the latency as far as possible. The results this time show only 5 paths versus 7 paths last time. And we brought our total length down to 180 with an efficiency of 81%. We got a little better trail, but what we clearly realize is that we have to go up and around the mountain range to get into the location B, Billings. The next stage is to take your trail and push those into the design area of SiteSync Pro. To do so, we want to make sure that the checkbox is checked for the trail you want. If we expand that, we can see that all the individual paths are also assigned. We will push those with More Actions, then View Save Paths. That will open up a template that auto-assigns paths if a match is achieved. What we've done in SiteSync is made it to where you design with your favorite radios, dishes, and modulations, then assign with a distant range, and a segment from hub count into microwave templates. In this case, Saragon_EX is the group name with 10 individual templates inside that group. All various bands, and modulation types and even dish sizes can be assigned by distances. What this pop-up has done on the fly is taken all 5 paths and auto-assigned them into the ranges they fit into. They get pre-designed as we push them. This is why back when we first talked about settings we said we really don't care about the frequency assignment. It's now being assigned automatically on the fly. Let's go ahead and rename this group to West Yellowstone, and then go ahead and push. We then will open them. This is assigning each one of those microwave templates and pushing those into our product called View Save Paths. Let's take a look in this new browser tab. Open that up into this group that we just assigned and check out our new design network. Down below we have all of those automatically assigned radios and equipment, and even our reliability was calculated showing how many 9s we have. All the path lengths are here too. And if we go into any one of these using the edit link, we will pull up the physical A to B design of that. This is where you can also save brand new microwave templates and groups, plus calculate your link budget. You can also further your design constraints or other parameters. We won't go into the design properties here, but we wanted to make sure you understood getting to this stage. Other parts of View Save Paths can be done with More Actions with those checkboxes and pushed into coordination or further engineering studies as an example. We can share those with our other engineers in our company or, if wireless applications is going to do your coordination and FCC filings, users can share with us. What you do as an individual user is you change the privacy share to read, write, and then, at WAC, with our mirrored account, we can pick those up and perform all the coordination, then FCC filings later. Users can see the progress flow in SiteSync. This concludes the case study of how to for the eFinder. Thank you.